friends. Eli here with Mystic Circuits. Today I'm very excited to show off a couple of patch examples using the Moog DFAM and various 0 HP modules that might help you get more out of it. I've been really enjoying using this synth in particular. Seems like techno just appears out of it, but it can also go into some very experimental, noisy territory. In this patch, you'll notice that I have a SQ1 synced with the DFAM. I find this useful for using the 0 HP modules since the DFAM doesn't have an LFO or really much else in the way of modulation except for the internal sequencer. Sometimes it's nice to have another sequence or gate sequence to add to control the 0 HPs a little bit better. I'm also using a compressor pedal since I think it really helps to get the most out of the DFAM. So in this particular patch, we have our 0 HP slew envelope, which is creating the glide pattern for VCO2, which is the only VCO that we're listening to. If I unplug the pitch sequence from the envelope, you can hear we have a static tone. So the pitch sequence is going into the envelope's input, and then the velocity sequence is modulating its release. So if I unplug that, you can hear we just have a sort of slewed pattern at its longest decay setting. Not super interesting. So changing up the pitch and velocity patterns gives quite a bit of variety to the way that the glide behaves. Unfortunately, the 0 HP slew only works on positive voltages. So if you send in negative values from the pitch sequencer, you'll just get a 0, essentially no change to the pitch. However, if we add the pitch sequence back in using the switch here, you get both the normal sequence and the glide sequence in conjunction. Which can lead to some interesting behavior. This is without the internal sequencer. Or rather, the internal sequencer is just going through the envelope. And now this is with both the internal sequencer and the envelope sequence. Get some interesting stuff that way. In this particular case, I also have our 0 HP AND gate. And if we want to hear that, we can turn up the external input, which is essentially ring modulating both of the oscillators together using the AND gate. nice to add hard sync to this in order to keep everything in phase. I'll go ahead and contrast that with just the internal oscillators. And then again with the ring modulator. And if we do them both as square waves, that sounds pretty evil. So in this patch, we have cross frequency modulation being controlled by the SQ1 in conjunction with a 0 HP and gate VCA. Basically, the DFAM gives you a voltage input to control the amount that VCO1 frequency modulates VCO2. But we are also using the 0 HP VCA to control the amount that VCO2 modulates VCO1. So if I open up the filter a little bit, we'll hear more FM. And if I increase some of these steps, this is full frequency modulation in both directions. Try turning on the pitch sequence for VCO2. Sometimes using triangle waves is more interesting for frequency modulation, since you get some more gradual values. I find that with a really long VCO decay, you get some weird kind of bongo, demented tabla kind of sounds. So in this patch, I am again using a 0 HP and gate VCA to control the amount of modulation, but this time it's on the filter. You can see the light lighting up whenever there's modulation being applied, coming from the SQ1. VCO2 going to our input, the output going to the VCF modulation. Obviously, the knob has to be all the way up. In this case, I'm using a pitch sequence with the pitches mostly left of noon to slow the second oscillator down enough to be useful as an LFO. You can hear at this note, it goes back into audio range for just a little bit more interesting of a note. So we can change the sequence on the SQ1 and get varying amounts of modulation. It's nice to add a little bit of the internal envelope to the beginning, just to add emphasis to the beginning of the note. If you get rid of it, the filter is only being driven by the LFO. Here's a patch which shows off the wonderful ways that you can use the DFAM to modulate its own tempo. Here we have the VCO envelope generator going through one channel of the attenuator, going into its tempo input, and then the pitch sequence goes into the other channel of the attenuator, which is going to modulate the VCO envelope decay. You can see as I change the envelope decay, the sequence gets faster. So changing the pitch sequence is going to give us a way to affect both the pitch envelope and the speed of the sequence at the same time. And of course, as I cover this attenuators, it turns more or less into a normally timed sequence. I can introduce randomness and chaos into it by uncovering the attenuators. Sometimes using an actual flashlight can have a much more noticeable effect. I'm also using the SQ1 to modulate the VCF decay envelope. With a little bit of noise going in, it lets you feel like there's a snare only on some beats, as opposed to just running in the velocity into the snare mix. There's a little bit more of an envelope to it. So this patch involves using a 0 HP envelope in a feedback loop with the internal VCO envelope. We're modulating the amount of slew with the pitch sequence. So you can hear the shape of the pitch envelope changing as I change the pitch sequence. It's more noticeable with a longer envelope. technically, when the envelope modulates itself, it's getting more of a logarithmic shape rather than a linear shape. By changing how long that voltage stays modulating itself, you're able to get some very strange envelope shapes. Especially when you turn one step up. Like, let's turn this first step up and everything else off. You can hear that the release goes all the way down here, and so the envelope goes to its shortest setting. And then that same envelope is being slewed over the rest of the sequence. Obviously, changing this length will have a pretty wide effect on the envelope shape. That'll be it for the Moog DFAM. It's a lot of fun, a lot of uses for 0HP modules, and a whole bunch of techno can be made. Thank you for watching.